Hello. I finally got this working. It is 7:30 right now, and my lighting is not great, so I'm gonna try to get the best shots I can. I think we'll make this work. So, this is the interrupts lab, and oh shoot. All right. Well, anyway, we've got the wires coming down to my potentiometer. Boy, that's terrible. You have to take here. Maybe if I put my finger over that, you can see it a little better. I did have one that had a clippy to it. I had just a regular potentiometer, and trying to affix wires to that was kind of a nightmare. I was really happy that I found this. Um, so I've got a plus and a minus going to the potentiometer, and then the signal just coming to the middle section of the board. I got one part coming out to port 3, which I'll talk about in just a second. Sorry, port 3. And then the other side going over to the um, analog port. Uh, so I chose port 3. I know that specifically in the lab you do mention port 0. I think that part of my frustration, I think my port 0 is not working. I think maybe it's defective or something, because I sat here for the longest time and I just could not get this to work. And finally I was like, you know what? Let me go back to like the demo and take some of that code and put it in what I was working on. And I put it on port 3, and bam, it worked. Now, I did have, I know your first inclination is going to be, obviously, if this is, you know, 8 in hex, that's obviously 011. So we're putting it on port 3. Um, I'm sorry, 1000. Um, so we're obviously putting that on port 3, but I did have that modified for 0 for port 0. So I'm pretty confident, 70% confident, I think, that port 3 or port 0 is just not functional. So for the purposes of this lab, I am just going to use port 3. Um, there were, I think, kind of like 3 sections to the lab. So I do have the voltage working there. We're going to just do a quick little, all right. This is hard to do with one hand. Um, there was a section about modify it so that it'll detect on the falling edge, and modify it so that it detects on the rising edge. I did notice that if you OR um, the polarity with a 0, that'll give you the falling edge. And if you OR it with a 1, the polarity, it will give you a rising edge. I will be 100% honest. I didn't really understand why that is. Because I feel like if you, I don't know, we can talk about it some other time. I kind of want to keep this short. I just feel like if we're ORing it to a 0, we're turning it off. And if it's high and then goes low, so in other words, the falling edge, like, wouldn't it? I guess maybe that's what it's matching with. Um, but in any event, sorry, I'm trying to keep this short. So in any event, those two did work. And then modify the code to count the number of interrupts detected. That is in there. It's going to do that. And then the last one, modify the code to produce an interrupt on both edges. And that's what I'm going to demonstrate now. Hopefully we can. Wish I had a tripod or something. Sorry. Oh, okay, that's not too bad. So I'm going to slowly raise this up. Boom, we went from 5 to 6, right around the halfway mark. And we get right up, not quite to 5 volts. It starts at 0, I think. And then we're going to go right back down. This is actually kind of hard to turn this with one hand. So right around the halfway mark, and it clipped one more time. So it did catch on both the rising and the falling edge. Let's do it one more time, just show off. Okay, there we go. And I will include the source code. I'll just go over it real quick. So it's very similar to the one in the demo. I did change the names just because I like changing names for things. And then here is the sort of the definition of the interrupt. As per your recommendation, I did take out the check to see which bit was actually interrupting because I only have one of them plugged in. So I took that out. Interrupt count. And so it's going to increment that, set it to 12, and then clear it. We did set, that's the user flag, so it's going to check when it goes through. Here's a whole bunch of setup. I did leave it for port 3. I do believe that port 0 is haunted or something. I did make the last line the global interrupts and in my while statement. So here's the meat of it. This is the actual ISR. And we're going to check if it is in fact 12. We're going to set it to the second line of the LCD screen. We're going to write the number and set it back to 4. And then this is the toggle bit. If we use the XOR, this will toggle it so that the next time it'll catch it. You know, if it was on the falling edge, next time it's going to do the rising edge. And now we are back to normal. And this one's pretty straightforward as we've done the analog lab, but we grab the analog lab for analog value from the analog port 2, and this was my math to get it to return in millivolts. If I did it in volts, it would have to be like a decimal. Otherwise, it's just 1, 2, 3, 4, 5. But I like millivolts better. I think that's a little more. It just looks more accurate, I think. And this is going to set the LCD. We're going to write that value, and then we skip to the next one over, and that prints the units. And then I just put the units next to it. And then this was for part of the demo. We were turning LEDs on and off. I commented them out because I hate to throw away code. And then, of course, MS delay just to slow things down a bit. Thank you.